you're tall. Good morning. We're not starting yet, so come in and find a seat. I always recommend that the opposite of going to church, come down front. We collect the money in the back, and the pictures are much easier to see the closer you get. But the escape is always easier in the back. And for those of you, I've noticed a couple times, this is a wonderful building. Its restrooms are downstairs in the back. So if you need them, that's where they are. My name is Bob Hopper, and I'm the president of the Chautauqua Science Group, also known as the CLSC Science Circle. And CLSC, when it started in the 1880s, science really was a key part of Chautauqua. And one of the reasons why it was so important is that the two leaders realized that if they had a cholera or typhoid outbreak, they were through. Because several summer places like this, including one in Glen Echo in the District of Columbia, had cholera and just died. So here they did things like no cooking inside your tent. They immediately put in as modern a centralized pickup of trash and sewage as possible. And for that kind of science, they were at the forefront. And then the big technological change that they struggled with was the telephone. Because half of the staff, and they were almost all Methodist ministers, half of the staff thought the telephone was an evil thing that spread gossip and rumors. The other half thought it was an incredible device for spreading publicity and getting people to come and coordinating your work. And the two who favored that were the president and the chancellor. So we got telephones very early. For the last 3 or 4 years, the science group has entered into a partnership with Chautauqua's Lake and Climate Initiative. And we've just been so glad to do that because, one, it's important and it is an area where science really can make things manageable, if not restorative. And sort of like cholera and dysentery and typhoid, the day that lake can't be swum in, can't be played in, can't be enjoyed, is a day before Chautauqua dies. So keep science going, and Mark Wenzel's going to introduce our speaker. And like I said, on your way out, put a couple of your $100 bills in the basket back there.
Thanks, Bob. Good morning, everyone. As Bob said, I'm Mark Wenzler with the Chautauqua Climate Change Initiative, and I, too, am really pleased to be collaborating with the Chautauqua Science Group, on many programs, broader than climate change. We, anything science-related to nature, sustainability, the environment, the lake, and so it's really great to have you guys as a partner, Bob. Thank you. This morning, I'm really pleased to introduce Brian Webb, who serves as Director of Campus Sustainability at the College of Worcester, where his primary responsibility is being to lead the college's efforts to promote environmental stewardship at an institutional level. This includes planning sustainability events and programs, working with faculty to incorporate sustainability into the curriculum, partnering with facilities to reduce energy use, and coordinating with the administration to implement policies and procedures that help elevate Worcester's position as a leader in environmental sustainability. Before coming to Worcester in August 2023, Brian worked at Houghton University as the Director of Sustainability and as an Assistant Professor of Environmental Studies. Under Brian's leadership, the college achieved a 46% carbon footprint reduction in just 10 years. Brian also serves as an active leader in the faith-based environmental movement and co-directs the Christian Climate Observers Program, which mentors emerging faith leaders by bringing them to the annual UN Climate Conference. His research area of interest centers around the intersection between climate change policy, environmental communication, and faith communities in the United States and elsewhere. And we were so pleased to have Brian and his whole family here this week. I know this is your guys' last day. We're going to miss you. We hope you come back. And we're really happy to have had Brian last week deliver the Interfaith Lecture. And then yesterday in a great conversation about earth care and faith traditions. And so today we're getting science, Brian, and really looking forward to your lecture, Beyond the Tipping Point. Thanks, Brian.
Now I'm trying to remember where my clicker went. Is it over there? Anybody see my clicker? No, that's the remote. That's okay, no worries. I'll do it the old-fashioned way by pushing the arrows. Well, thank you so much for the kind introduction, Mark, and thank you so much to everyone at Chautauqua for hosting us this past week. It's been such a joy and a pleasure to be here. I've really, really enjoyed, our whole family's enjoyed our time. I'm very excited to be speaking here with you today. This presentation can be thought of, well, part of it, I teach a course called Global Climate Solutions, and this is kind of the trailer for that course. This is that course packed up into one lecture. But you can also think of this as sort of a 30,000-foot view of how we collectively, as like a globe, are doing on trying to address climate change and what's it going to take to get to where we want to be. So this is sort of a snapshot of our progress and a sort of roadmap, rough sketched roadmap of where we want to go. So we're going to walk through 5 sections here. We're going to start with a very quick crash course on Climate 101. Ask the question, how are we doing? That's kind of the depressing part. And then we're going to look at what will it take to get to where we want to be. Key tipping points, not in the usual sense of how we use tipping points. I'm thinking of positive tipping points here. And then lastly, mobilizing solutions for the future. So first of all, looking at just a very, very quick, there are entire graduate programs on this. We're going to do just a 4-minute overview just to make sure we're on the same page of understanding what climate change is like from a scientific perspective and what you need to understand around that. So basically surrounding the Earth is a collection of gases that make up our atmosphere. That's where we all live. That's where all life exists. And within the atmosphere, there's also a collection of gases that we refer to as greenhouse gases. Now, you can see the examples of what those are listed on there. Water vapor is the most abundant, but the other 4 underneath water vapor are the most significant in terms of influence on the overall heat balance within Earth systems, and you can see some of the sources listed for where those different gases come from. Now, when energy from the sun enters the Earth's atmosphere in the form of visible light or ultraviolet light, it warms the planet up. The planet then re-radiates that back in the form of infrared radiation. Some of that escapes into space, but some of it gets trapped by these greenhouse gases because, like a greenhouse, it traps the heat, warming the planet up. And this is a really, really, really good thing because without this, the Earth would literally be a frozen ball of ice with an average temperature of around 0 degrees. That's 0 Fahrenheit, by the way. So Earth would be a frozen ball of ice. As much as I love winters, and I miss the winters of Western New York when I used to live here, I don't want to live on a frozen ball of ice. That's a bit too much. So instead, these greenhouse gases keep the Earth a relatively average 59 degrees Fahrenheit, which is really kind of the sweet spot for a diversity of life to thrive on our planet, for human civilization to thrive on our planet. That's really kind of what we would ideally want it to be in terms of a global average. The problem is that just like with ice cream, too much of a good thing can be really problematic. So right now, we have been burning ever-increasing amounts of fossil fuels, which leads to ever-increasing amounts of greenhouse gases going up into the atmosphere. essentially thickening that warming blanket that we have around the planet, thus amplifying that natural greenhouse effect. So we have this natural greenhouse effect that keeps the Earth a nice, relatively stable temperature. These added greenhouse gases in the atmosphere are thickening that much in the same way of on a chilly evening, if you put a warm blanket around you, it warms you up. Put a thicker blanket, it warms you up more to the point where maybe it's a little too much. And that's kind of the position we're in today, because all of this added heat content into the system has a lot of repercussions that are not so good for the planet and that are not so good for people as well. Stronger storms, larger wildfires, sea level rise because of melting ice caps, we have spreading diseases, we have decreasing food production, more droughts, more floods, a whole host of different things that we're all familiar with and see in the news quite frequently now, all driven because of this extra heat content in the system. So if you look at this from the perspective, okay, what do we need to do about this? Well, the answer that the UN says here is we need to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Anthropogenic is just a fancy word for human caused. So I think basically what we're trying to do is we're trying to avoid that dangerous part there. We've got extra greenhouse gases in the atmosphere. We're trying to make it so that we don't have so much of that it's dangerous for where we are. That's the quick climate overview. Okay, so how are we doing on our progress here? Well, we have two key ways of evaluating our progress. There are something like 26,000 indicators related to global warming, but there are two particularly important indicators that show how we're progressing on this. One is actually looking at carbon dioxide concentrations in the atmosphere. We have been taking direct measurements of that since 1958, and we have proxy records going back thousands of years. The other one is to look at actual global average temperature. And that to do that, we have thousands of temperature stations all around the planet that scientists collect all that data, average it out, and we've been doing this with reliable records, direct records for 140 years. And again, proxy paleoclimate data that goes back many thousands of years before that. So, first one, how much carbon dioxide is okay? We know we're adding extra carbon dioxide to the atmosphere. How much of that is okay? At what point do we get to dangerous? This gentleman here is named James Hansen. James Hansen is the former director of the NASA Goddard Space Institute. And Dr. Hansen was the first person to sort of address this question, and he did so in a testimony before Congress back in 1988. And this was sort of the first time, not the first time the world had heard about global warming. We've been knowing about this for a long time. As I said in my talk the other day, the first scientific calculation of how burning fossil fuels would increase the Earth's temperature was done in the 1890s. So we've known about this a long time. But this is the first time it really came into the public consciousness in a significant way. And Hansen said, basically, if we want to enjoy the planet in the way that we have, relatively stable, ideal temperatures for human civilization to thrive, we need to limit carbon dioxide concentration to no more than 350 parts per million. Parts per million is just the way that we measure the concentration of carbon dioxide in the atmosphere. How are we doing on that? Are we on track for 350 parts per million? This is the direct measurements we've been taking since 1958 at the Mauna Loa Observatory in Hawaii, where we began doing this, and this is where 350 parts per million is. As of yesterday, we are at 428 parts per million. Incidentally, when Hansen testified, we were right around that 350 parts per million level, and we continue to go up. The United Nations Framework Convention on Climate Change was signed in 1992, and we continue to go up. The Paris Agreement was agreed upon in 2015, and we continue to go up to where we are today, which is 50% higher than at any point in human history before the Industrial Revolution. So greenhouse gases began to go up after the Industrial Revolution. They had never been above 280 parts per million in all of human history, or all of recorded history, or all of paleoclimate history that we can look back. Now they're at 428. Not doing so good on the CO2 metric. What about the temperature metric? How much temperature increase is okay? Well, in Paris, world leaders gathered together and, informed by the science, agreed upon a target of keeping, minimizing global temperature rise to less than 2.0 and ideally around 1.5 degrees Celsius. That being the goal of what they're aiming for. Even with this amount we still have very significant negative impacts. Like, we already see significant negative impacts. So we know that those are coming, but trying to establish some sort of realistic target here that we can do. How are we doing? Are we on track? This is data that comes from Climate Action Tracker, which is an NGO that basically looks at the top 40 or so emitting countries in the world, looks at their pledges, looks at their policies, looks at the targets they've set, and kind of charts out, based upon all of that information, how are we doing, what are we going towards. And right now, if you can't see that, we are on track for about a 2.7 degree temperature rise by the end of the century, quite a bit above our 1.5 or 2.0 goal. A recent report from the UN that came out last October puts us more like 3.1. So definitely not on track there, and currently we're around 1.3 degrees Celsius. So we're already almost breaching that ideal target of 1.5 of what we're aiming for. This is just an interesting little visual. Is it playing for you there? Mine's not playing. Okay, it doesn't like that. We'll skip that. In fact, 2024, we did cross the 1.5 threshold. If you'll remember, 2024 was a very, very warm year. 23 and 24 were El Nino years, so it tends to jump up a little bit more there. And in fact, in 2024, the average temperature was above 1.5 degrees. And just out, literally a few days ago, what is this, June 5th? Oh no, that's June 5th of last year, sorry, my bad. The report from the World Meteorological Organization, they expect us to permanently cross the 1.5 threshold sometime in the next 5 years, meaning that the average temperature, so 2024 we crossed it, we'll probably go back below it in 25 because El Nino's finished, but they're saying that rate of increase is increasing so much that in the average year we will be above 1.5 sometime within the next 5 years. Is anyone on track looking at it globally? The green category there represents countries that are on track for a 1.5 degree future, and if you look closely on the map, you'll see that there are no green countries. So there are no countries that are actually on track for a 1.5 target. Yellow countries there's 10 of them listed, are ones that are on track with a 2.0 compatible target. Interestingly to note, most of those are in the developing world. The only wealthy country there is Norway, that is in the yellow. And other wealthy countries like the US, most of the rest of Europe is insufficient. And actually, this hasn't been updated, well, this was last updated March 2025. I think that the US now, since we've abandoned our goals, is beyond the orange. We're probably more in the red or gray one there. So not doing so well. Okay, what will it take to get to where we want to go? We know we're not doing what we need to do. What's required in order to get where we're going? For this section, I'm going to look at something called the State of Climate Action Report. And granted, it's about 2 years old, but it has really great information. And basically the goal in this report is they're trying to develop a pathway to achieving the 1.5 degree target. So this is kind of ambitious, but the thought process here is, okay, if we're going to achieve, in 2023, if we're going to achieve the 1.5 degree target, what are the key indicators that we need to follow to be on track for to actually get there? Their key finding, and we're going to look at it in a little more detail, is that yes, it is possible, it's still feasible, but it would take highly ambitious global effort in order to get there. And the analogy that I've seen most frequently used is kind of on par with what it took for us to ramp up the war machine in World War II to fight the Nazis. It was a very concentrated, very intentional global effort to ramp up production so that we could develop the military enough to be able to actually fight Germany and Japan. That kind of intentional effort is sort of the kind of intentional effort that's needed to actually get to where we want to go here. 3 specific things that we need to achieve if we're going to be on path to that. 1, we need to peak emissions by 2025. 2, we need to reduce emissions 43% by 2030 and 60% by 2035, and then need to achieve net zero by 2050. Net zero basically means either emissions are down to 0 or emissions are down low enough that new added carbon sinks, like reforestation work or technical sinks or whatever, are enough to compensate for the remaining emissions there. So first, What will it take? We need to peak emissions by 2025. By the way, if you hadn't noticed, that's this year. Short answer here, we're going to dig into this more in the next section. This seems very likely, actually. This is a good one. It is very likely that we will peak emissions this year, if not already last year. Of course, we can't know until we get a whole year of data after the year, right? So it's very possible we peaked in 24. Seems likely we'll peak in 25. Emissions increased by less than 1% last year. So we have some charts. We're going to dig into that more in a bit, but that one seems good. Reduced emissions 43% in 5 years, 60% in 10 years. Don't panic. I'm going to put up a very busy image here. You don't need to read it. These are the 42 indicators that they are using in order to measure our progress on that. So if we're going to reduce 43% by 2030, 60% by 2035, then we need to achieve X amount on each of these 42 indicators. Only one of those are we on track for right now. And that's actually percent of new car sales that are electric. So globally, we're actually meeting that. We need to have an exponential increase of adoption of electric vehicles. That's only one of 42 indicators here, but it's the one that we're on track for. That's good. There's about a half dozen or so that we are almost on track for, like pretty close, including the share of zero carbon energy in electricity grid. Solar and wind have been expanding so rapidly. We're almost on track with the rapid growth we need there. There's a whole bunch that we're not even close to. We're going in the right direction, but we're off by an order of magnitude. That's actually about half of the indicators on here, and there's a handful that we're actually going the wrong direction on. So number two, these reducing emissions targets, we're not doing good on those. Net zero by 2050, this one's kind of interesting. So most countries, around 142 of them, have net zero goals that they've established. And that represents about 3/4 of all emissions. So that's the good news here, is that most countries acknowledge this. The whole international diplomatic process that was established with UNFCCC and through the Paris Agreement has been pretty effective at mobilizing countries to set these targets. Now, whether countries are actually achieving these targets is a whole other question, but at least we have countries moving in the right direction, making ambitious efforts towards that. Bad news, of course, the United States with the new administration has abandoned our net zero goal, and that represents 11% of global emissions. We are the second biggest emitter on an annual basis. And then a number of really large and influential countries that you see listed there have targets a little bit too late. We're trying to get net zero by 2050. China has a 2060 goal. India has a 2070 goal, et cetera, et cetera. I will say, though, that China has a track record of setting kind of lazy goals and then blowing past them really early. So I'm somewhat optimistic that China may actually get to net zero way before their goal, probably way before us. Basically, what we need to do is to bend the curve. I know this is a little bit busy here. That black line is the trend of emissions over the past, what's the year there? 50 years. The gray area shows how we were headed before the Paris Agreement. So before the Paris Agreement, we were headed for a 4 to 5 degree temperature increase. That's into like apocalyptic scenarios. So that's where we're headed. Those blue ones where it starts to turn over, that's what we're on track for now. So you'll notice this is where we are in the moment right here, where the arrow is pointing. We are at that inflection point, that tipping point where it's actually tipping over and emissions are beginning to decrease, heading towards those blue areas. Now, the yellow area is where we'd like to go, that yellow line. That's if we're going to achieve a 1.5 degree future, that's what emissions have to do. And that's, frankly, we're not going to do that. I think it's time to stop talking about the 1.5 goal because it's frankly out of reach. But we need to bend the curve. I want to hit on some tipping points now, not in the traditional sense of how we use the term tipping points in climate science, because usually in climate science, we talk about tipping points in terms of dieback of the Amazon, or melting permafrost, or melting ice sheets. That's usually how the term tipping points is used. I want to talk about some hopeful tipping points, things that give us some hope for the future. And specifically, there are 3 areas. There's been a lot of like non-hope stuff that I've hit on up till now. So hopefully you're not too discouraged. No one's left yet, I think, so that's a good sign. This section here are some reasons to be hopeful, some reasons to be positive. And I think particularly these 3 areas are some tipping points that really bode well for our future, specifically that we are approaching, if not at, peak emissions, the rapid growth of wind and solar, and the rapid growth of electric vehicle adoption around the world. So first, we're nearing a tipping point. This looks at emissions over the course of the past 150 or so years, and you see that exponential increase. Up near the top there, you see the COVID dip, where it drops down. But then if you'll notice, after the COVID dip, it doesn't really bounce up very much after that. And that's because we are beginning to crest that. We are seeing that crest coming. In fact, on a per capita basis, we peaked in 2012. So globally, on a per person basis, emissions peaked over a decade ago. China probably has peaked last year. This is new data that is just out, and you see that in the first quarter of 2024 compared to the first quarter of 2025, China's emissions actually went down. This is really meaningful. It's not the first time China's emissions have gone down, but it is the first time China's emissions have gone down, and it wasn't because of either COVID or a drastic change in their economic policies. So every other dip that China has had can be explained away through other variables. The only thing that can explain why China's emissions are going down is because they are racing forward in implementing clean energy. We're going to show some charts that show that in a moment, but China peaking emissions is really, really good news for the future. Many other countries peaked long ago. The US peaked around 2007. Europe peaked decades ago. So there are a lot of major emitters that, in fact, did peak emissions already. 3 of the 4 largest economies in the world are actually decreasing their emissions right now. So first one, that looks great. Rapid growth of wind and solar. Wind and solar are now the fastest growing sources of electricity in history. This is not the first energy transition the world has experienced, but it is the quickest energy transition that the world has experienced. Never before in our history have we transitioned so rapidly from one dominant form of energy to another. In fact, the International Energy Agency declared solar energy to be the cheapest electricity in history. This was from 4 years ago, and solar prices have continued to go down since then. So just imagine that in the context of this great challenge of trying to address climate change. The cheapest form of energy in almost every place in the world today is clean energy. It's solar. And if it's not solar, it's probably wind, which is why 90% of new energy around the world last year was renewables. 90%. This bodes well for the future. We hear a lot about how data centers are major energy hogs, and they are major energy hogs. But what's the response to that? Well, power companies want to put in the cheapest form of energy possible. It's to their economic best interest to do that. And even without subsidies, the cheapest form of energy are wind and solar. So that's what we're going to see continue to put in. This is the adoption rate or installation rate of wind on the left, solar on the right. And this is only over a period of 23 years here in this chart. So this is a relatively short time period. In fact, in solar, all you got to do is look back about 13 years to 2010. It's almost at 0. And then since then, it has gone up incredibly rapidly. This goes through 2023. I looked up the 2024 number for solar, and it lands all the way up here, continuing that very steep adoption. In fact, in 2024 alone, China installed more solar than the US has in our entire history in 1 year. And that's just the rapid rate at which things are installing today. 2.2 terawatt hours of energy from solar today. Tipping point number 3, electric vehicle adoption rates. Despite everything that we're hearing in the news about electric vehicles in the United States, in spite of subsidies being removed for electric vehicles here, their adoption around the world continues to skyrocket. In 2019, electric vehicle sales represented 2.5%. Now they're at 20%. That's in just 5 years, gone from 2.5% to 20%. That's because new technologies, when they are adopted, tend to follow what's called an S-curve, which basically looks like an S. It's got an exponential rise on it. It's the same thing that happens with VCRs or cell phones or other new technologies that displace old ones. In China, electric vehicles are cheaper than gas-powered engines. In Norway, 90% of new vehicles are EVs. The adoption rate on these is rapidly, rapidly growing around the world. Even in the United States, Where we have polarization around electric vehicles, they are continuing to grow. You see stuff in the news about them slowing down. That's basically saying that their growth rate is slowing, but they are still growing. Lastly, before we jump into some question time here, I want to talk about how do we get there? How do we actually mobilize the solutions? We saw some examples of some great indicators that are showing some hope for the future. How do we get to where we want to be? The resource I'm going to point you toward here, and I really highly, if you're interested in this topic, suggest that you look at the Project Drawdown website. Project Drawdown is sort of the world's go-to leader on quantifying climate solutions. So what they do is they look at all the technologies that are out there today and say, how much could this be scaled globally, like from a realistic perspective? How much could be scaled globally, and how much carbon is this going to sequester? How much is this going to remove from the climate system? And they look at it from a sources and sinks perspective. So on the left-hand side here, we see sources of carbon emissions. About a quarter of those are from electricity, a quarter of those from food, agriculture, and land use. Then we got industry around 20%, transportation around 15%, buildings and other stuff. This is on a global scale. In the U.S., it looks pretty similar. Transportation's higher in the U.S., food and agriculture is lower. On the right-hand side, we have sinks, land and ocean sinks. Forests are major carbon sinks. There's a lot of carbon sinks in soils through various forms of agriculture. We have sinks in the ocean. We have manufactured sinks now. Of course, the problem here is that we have a lot more sources than we do sinks, and that extra carbon staying in the atmosphere is what we need to deal with. So from a drawdown perspective, they're looking at how can we either reduce our sources or increase our sinks. Either of those creates solutions. And of course, as you might guess, there's no magic formula here. The idea is, well, we need to do a lot of these. So we need to decrease sources all over the place in all these different sectors. We need to increase sinks as much as we can. And they divide it out into these different sectors of society, and within each sector are subsectors. Don't worry if you can't read the specifics here. You don't need to. Those bubbles simply represent different subsectors. The biggest orange one you see there has to do with shifting production and electricity. That's clean energy that we're talking about. That large green one that you see there has to do with waste and diets. A big chunk of reducing emissions has to do with reducing food waste, changing how we eat, stuff like that. Within the drawdown framework, they only look at solutions that are currently available. So you won't find fusion on here. You won't find futuristic solutions that haven't proven themselves. They only use solutions that have proven themselves, that are economically viable, that are already growing in scale, that have a net positive impact, and ones that they could quantify. So you might have a favorite solution that you look at drawdown and you're like, I don't see it listed. Well, it might just be because they haven't gotten around to quantifying it yet. There's a whole lot of science that goes into quantifying these, and so these are only the ones that they have quantified so far. Within the electricity sector, for example, this is only about a half or so of the many solutions they have listed in electricity, and you'll find things that you expect there, like wind and solar, but you'll find a whole bunch of other things too, like heat pumps, like LED light bulbs, like what else do we have here? Methane biodigesters, biomass power, district heating, micro wind turbines. There's a whole bunch of different creative solutions, and they actually quantify for each of these solutions how much of this could result in a carbon solution, could reduce emissions. To what degree could this one do that? Food and agriculture, we see things like conservation agriculture, plant-rich diets, doing different forms of rice cultivation, indigenous peoples' forest tenure, because indigenous peoples are really, really good at protecting forests in order to preserve the carbon sinks in those forests. So there's a lot of creative and interesting solutions. Transportation, of course, electric cars are listed there, but that's only one of a dozen or so other transportation related. And it's not even the biggest one, actually, within the transportation sector. You have things like public transportation, more walkable cities here, high-speed rail. All of these things are different forms of climate solutions. So when we think about climate solutions, we tend to think along just a few obvious things, right? But the reality is that there are many, many, many dozens, hundreds of different things that can be implemented to varying degrees of scales globally to help contribute towards reducing emissions or to increasing carbon sinks around the world. And implementing all of these provides so many different avenues of solutions for being able to address this. I'm going to shift to be a little bit interactive. I only got one more slide after this, but I want to ask your question first. So Drawdown actually ranks all of these solutions. And I'm curious, what do you think are the ones that have the biggest impact quantifiably? So they quantify all of these. Which ones do you think? Just shout it out. Okay, plant-based diet, I think I heard. Transportation's a broad category. Let's go more specific. You've got
Carbon removal from the atmosphere.
okay. There's a variety of different forms of carbon removal, right? Okay, yeah, they have several different ones on car transportation. They do have one on more efficient aviation on here, I think I heard. I'm realizing the acoustics aren't great here for. Okay, nuclear. Reducing food waste, great. I wish this were bigger here. This is going to be hard for you to see, so I'm going to try to read these out. This is ranked according to the biggest possible impact. Number 1 and 2 are not surprising. We have wind and solar, right? There's a reason why we hear about those a lot, and that's because they really are the biggest impact ones. But look at 3 and 4, plant-rich diets and reducing food waste. Those are things that cost us $0 to implement and are literally the number 3 and number 4 biggest climate solutions that are out there. In fact, those things will save you and are better for your health. So I find that super encouraging, that 2 of the biggest impact climate solutions are things that are literally free and are better for me to begin with. Tropical forest restoration here. Clean cooking is absolutely one of my favorite. What this is referring to, how many of you have heard of clean cook stoves in the developing world, clean cook stove projects? A few of you. So in the developing world, a lot of people still cook over like what are called open fire cook pits. So frequently people have to walk very long distances to forests to collect firewood. Usually it's women that do this, that bring the firewood back. They cook in enclosed spaces over these open fires. It's very unhealthy. There's significant health impacts that come from that. It's very disempowering for women because usually in many of these cultures, it's the women that are expected to do that, and they spend hours doing that, which means those are hours that they aren't able to go to school or to study. So clean cook stoves basically flip that on its head by providing a cooking option that requires much, much less fuel. So it's a lot less time walking those long distances to gather firewood. It's much healthier because it addresses all kinds of indoor air pollution problems. Oh, and by the way, it's one of the biggest climate solutions we have globally right here as well. Family planning and education, that basically has to do with what happens when you provide education and access to health care for women in the developing world. What happens is those women go on to pursue education, to get jobs, and to have fewer children and to have them later in their life, which helps stabilize population growth in areas of the world where population is growing very rapidly. Incidentally, that has a climate-related impact to it as well. We've got more solar there. We've got managing refrigerants, because refrigerants, if you aren't aware, those things in your refrigerator or in your car AC unit or whatever, those refrigerants, typically capture heat about 1,000 times more than CO2. So when a small amount of those leaks up into the atmosphere, that molecule is capturing 1 to 2 to 10,000 times as much heat as a similar molecule of CO2. So managing refrigerants better is critically important for this as well. There's a whole host of different solutions on here. So I find this to be an encouraging thing. It's a difficult moment for us in terms of addressing the climate crisis because we're really not doing a good job of it. We're not on track for where we need to be. We talked about that a lot at the beginning of this lecture. It's a discouraging thing. But there are reasons to be optimistic. There are things that are tipping faster than we expected in the positive direction. There are solutions that are making this into a better world right now. And there's a whole host of other climate solutions that are scaling up, that are making society better, that are providing climate solutions in the long run as well. And a lot of these things are within our reach of things that we're able to be involved in as well. I think I'm going to stop there and open it up for questions that you guys might have. And I know I think there's a mic here, so do you want people to line up the mic? That might be helpful. I had a hard time hearing feedback from this echoey building, so.
Yes, hi. A couple years ago, we had some MIT people here talking about new generation nuclear.
Yeah.
And I've heard other climate scientists say it's really a very effective solution. Just, you didn't mention nuclear, just wonder your thoughts.
Yeah, nuclear's not in the drawdown menu, mostly because I think there's some of the new generation stuff that's still not like out necessarily into the market yet. A lot of new nuclear ideas that we understand the theory really well, but aren't necessarily on the market. And drawdown only looks at things that are on the market and are increasing in adoption. So that's not like an intentional exclusion of nuclear from the drawdown folks. It's just that it falls outside the parameters they've set of things they can quantify because they're already increasing in market share. Personally, I'm a big fan of nuclear in the sense of we have to have something that is consistent, stable power supply. And the only thing other than battery storage, which battery, actually, I could have put battery storage as a number 4, like positive tipping point, because batteries have gotten so much cheaper than they used to be and are really a lot more reliable. But we do need that consistent, stable power supply, and nuclear is a way better option than fossil fuels are for human society. So I am a fan of that. I wish we would have a little more focus on nuclear. I think there's some renewed focus there. But I would say I think that's a necessity as part of this. Yeah.
You started answering my question about batteries. It seems like battery technology is the bottleneck in a lot of these things. Yeah. How about you? What do you know about like iron phosphate and new kinds of battery technologies? Are they promising?
I don't know a lot about specific battery technologies, but you're right. Battery technology has greatly increased in terms of storage capacity and greatly decreased in terms of cost just in the last 5 to 10 years. So batteries as a viable climate solution are very much there. It's very much forming an integral part because, of course, with solar and wind, the sun's not always shining, the wind's not always blowing. We need ways of being able to store this. So batteries are definitely there. I would actually say the bottleneck right now isn't batteries. The bottleneck right now is the permitting process. That a lot of the problem with solar and wind is that it takes 2 or 3 years sometimes to get the permitting to go through. There was a big push before the last election to get in the last Congress an energy permitting reform bill through. And it actually would have been a technology neutral one that would have sped up permitting for all kinds of energy, not even just clean energy. So there's a little bit of a trade-off there, but the reality is that would have really benefited our progress on climate change because it would have sped up clean energy permitting. That's the big bottleneck right now.
Thank you.
Yeah.
So, along with the discussion of batteries,
Yep.
A lot of people I talk to are resistant to electric vehicles because of the environmental impact of,
Yep.
of the mining of the
Yep.
minerals. Can you address that at all?
Yeah, absolutely. It's a major problem. The mining of the critical minerals that go into batteries or frankly that go into solar panels as well is a major problem. It's an environmental problem. It's a human rights problem. It's also a solvable problem. It's a lot easier to solve that than it is to solve all of the negative effects of burning fossil fuels. So you're absolutely right that it's a problem, that it's something that needs to be addressed. I think it's a lot easier to address that effectively. We have models of how you can address human rights issues and environmental degradation issues with mining minerals. It's a lot more solvable than the problem of burning fossil fuels, which is effectively what got us into this spot to begin with. So that's my thought.
Hi, good morning. Stacy Collins, Arlington, Virginia. Thank you for your excellent lecture, and I apologize if you covered this in the first 5 minutes of your lecture. I walked in a little bit late.
That's okay.
I wanted to hear your opinions on how we sell these concepts to resistant people.
Yeah.
And it was probably for everybody in the audience really disheartening to see Biden's entire green energy legacy dissolve last week.
Yep.
But at the same time, looking at it from a jobs perspective, that should be resonating with states and policymakers and lawmakers who have been resistant. And I read a statistic about coal mining industry employing maybe 40,000 people, high-risk, dangerous occupation, versus close to, this is in the U.S., close to 300,000 now in the wind and solar industry. a lot safer, and red states that benefit from this. Texas is one
Right.
of the biggest producers of wind power in the United States, apparently. Correct me if I'm wrong, but so there's clearly an argument to be made to persuade, resistant policymakers that this is in their best interest, this is in their state's best interest. How can we do a better job of that?
Yeah, you're exactly right. I mean, the clean energy industry employs far more people than the fossil fuel industry does, even though it's a much smaller portion of our electric grid at the moment. It's a great job generator, and that's one of those talking points that I wish were brought up more, because if we're concerned about jobs, we're concerned about the economy. Let's talk about clean energy. Clean energy is a great job creator. You had a number of good points there that I was wanting to hit on. How do we talk about it? I think the key is you just talk about how good the solutions are. I think the more we talk about, a big part of the problem now is that those who are resistant to addressing climate change, there's a term we refer to it in the social science literature, it's called solution aversion, and that is the perceived solution they don't like. So if the perceived solution is big government, heavy taxes, controlling what you can and can't do, of course a ton of people aren't going to like that. Like, not many people do like that. But if the solution we're pointing to is like, oh, since I put solar panels on my house, I haven't paid an electricity bill then. Or since I got an electric vehicle, I cut out $200 a month in what I used to pay in fuel costs. Or since I stopped eating beef, I feel so much healthier and I dropped 10 pounds. Like, the more we hit on the kinds of things that have enriched and make it personal, have enriched our lives by stepping into many of these kinds of solutions and being involved in these, the more desirable that becomes towards others, and the less they resist those solutions, because it's no longer the big government solutions. It's now suddenly solutions that make my life better as well, and make the life better of my friend who has talked about it. And I think personalizing it really makes a big impact there too.
Hi, I'm a secondary school teacher, and so my question comes from that background. I'm a secondary school teacher, and so my question is related to your work at Worcester, and it's related to the last question. What are the ways, or what are things that you see that get young people motivated, sort of in that sweet spot between defeatism and apathy, where there's empowerment to do something? What are things that you have seen that really have an impact there?
I'm so glad you asked that. It's such a tough question. You've probably noticed this too. I've noticed, like, around 10 years ago, I still had to do a little bit of work convincing people. Those who were convinced, they were all in. They were really active. Maybe this is something about millennial generation. But I still had some. Today, I don't have to do any convincing. Every college student gets it. Even conservative college students are concerned about climate change. My wife was a secondary school teacher for a long time, and she spent a bunch of time teaching in a small rural school just a couple counties over from here, super, super red district. Every student in her class was like, would wear red Trump hats to class, kind of. And she asked them once, what are some important problems in the world today? And like half the students in the class said climate change. So young people, regardless of their political persuasion, get it, that this is a problem. What I have found the problem to be is that it's hard to mobilize young people today because they think there's nothing I can do that will affect change. That the political leaders have so shut us out and are so corrupted, and I won't disagree with that, that there's nothing I can do to affect change. And that's the hard part. So in my approach to interacting with college students, one, I try to give them some hope that you can affect change. Two, I try to point toward things like things up here. Some of these are easily within reach of what you can be involved in. And some of it is just this, like, this is too big of a problem to say that I can't affect change. Christiana Figueres, who is the author of the Paris Agreement, a Costa Rican diplomat, refers to this as stubborn optimism. And this idea being, I'm not optimistic because I think that we're going to get where we want to go. Like I already said, 1.5 is dead. But I'm stubbornly optimistic because, gosh dang it, that's what the world needs right now. And that's what I'm going to do and step in. I'm going to tell one quick story that I think might help you out with this. I tell the story a lot. Some of you may have heard it on Friday. After the first Trump election, I had a number of students in school who were kind of disheartened. And so I tried to provide, okay, what's something we can do to help people feel like they have some sort of agency? So we started the Do Something table. And the Do Something table was every Tuesday at lunch, we would show up in the campus center, and we would all make calls to our congressman. Tom Reed was his name. He was a Republican on the Ways and Means Committee, a Republican who would acknowledge climate change is a big deal. So we're going to call Tom Reed, and we're going to ask him every week to join the Bipartisan Climate Solutions Caucus. There's about 15 students involved in this. So we called every week. It took 2 minutes of your time every week. And at the end of the spring semester, he joined the Bipartisan Climate Solutions Caucus. We're like, okay, was that us? We have no idea. Maybe he was going to do it anyways. In June, I was sitting in his office in D.C. with his energy aide. And when I said I was from Houghton, New York, she said, "You're the ones who got us to join the Bipartisan Climate Solutions Caucus." So here's my point. Sometimes it feels hopeless on these big issues, but if 15 college students giving 2 minutes of their time a week can get a member of Congress to do something, maybe there's hope. So hang on to that as your hat for interacting with your students.
What role do you see, both positive and negative, of AI in this environment?
Another great question. Of course, the negatives with AI is it is a tremendous energy hog. It can't be overstated how big of an energy user AI is. In fact, the only reason that we didn't actually tip emissions 2 or 3 years ago is because of AI. We were on track, and projections were thinking we were going to tip in 2023. And the only reason it didn't happen is AI delayed it from the big energy use. So that's the big downside. Of course, the upside is that we're still exploring the limits of what AI can do in terms of helping us create more efficient systems. One of the biggest barriers to effectively addressing climate change is the complexity and the clunkiness of our electric grid system. Our electric grid system is so inefficient. There's so much lost in transmission. We don't have the ability to trade energy back and forth between different regions. That big winter storm that knocked Texas out a few years ago, one of the main reasons they couldn't do anything about it is because Texas is its own isolated grid. If the Texas grid were in more communication with neighboring grids, then they could have pulled power from other grids to address that. So part of this problem is we have this. So can AI help with that? Absolutely. This is the kind of thing that AI can do best, is figuring out these complex energy systems that are really difficult to figure out how to run efficiently. So there is the potential for some. I'm not an AI expert. I'm not a computer tech expert. But I know that some of the key problems we have with climate change are really complex technical problems that, well, a very fast-thinking computer can probably help us figure out a better system on. Is it on the average like a positive or a negative? I think that remains to be seen.
Excuse me. First, may I say that I've seen many presentations. I think yours is one of the better ones I've seen in the last 2 years. Really.
Well, thank you.
But my comment, if you will, is this. For the last 3 years, the world consumption of oil, petroleum, has been roughly constant, in spite of all the wind, power, solar, etc.
Yep.
And the reason for it appears to be what the United Nations said about 2023. The world's population grew by a net 97 million people. That kind of offsets all that we've been doing.
Right.
My question, whimsically, if you will, is people pollution part of our problem?
Yeah, so I love talking about the population question, because so many people get really oh, we're going to talk about overpopulation. That kind of makes me uncomfortable. The answer to overpopulation is educate women. That's it. Educate women in the developing world. And quite honestly, that's the fastest, most effective pathway to stabilizing global population. So anyone who is doing education work in the developing world, they're doing climate work, basically. That is as important as any of the other things. Oh, and by the way, it brings a whole bunch of other human rights benefits along with it as well. So yeah, let's educate women, provide access to health care in the developing world, and that is no longer an issue.
Yeah, a lot of the solutions that you're talking about here all deal with emissions. So I kind of wonder whether or not there are certain types of sinks that could be encouraged. And one of them that I think of is whales, because, parallel to the Industrial Revolution was a decimation of the whales that were in the ocean. And think about it, a whale sequesters all sorts of carbon out of the environment and takes it to the bottom of the ocean where it can be recycled geologically into the earth. And, I'm kind of wondering whether or not one of the solutions that should be on the list here is encouraging the sink of the blue whales, that weigh 200 tons and would take plenty of carbon out of the environment.
Yeah, I never would have heard of that as a sink, except that you must have gone to the film presentation from last week. I was able to meet with we had a film presentation that hit on whales as a carbon sink. There's a ocean sinks category in drawdown. There's not a lot of things yet quantified under there. Again, I don't think it's because their drawdown doesn't think that there are good solutions there. It's just that they haven't gotten around to quantifying that. This is sort of still a work in progress. But what the gentleman is referring to is that, so within kind of the trophic sphere of creatures, when you get to like the sort of the apex creatures like whales, what's happened is by then a lot of the carbon has trickled. So like phytoplankton take in carbon from the atmosphere on the surface of the ocean. Those get eaten by krill get eaten by whales. And so you've got carbon basically kind of accumulating into these larger and larger animals. And when whales die out, all of the carbon sequestered in their body falls down to the ocean floor. So the ocean floor is a massive carbon sink, enormous carbon sink, which is part of why this move towards mining seabeds is so disturbing right now. It's because mining seabeds stirs up all that carbon, and some of that gets back out into the atmosphere. So yeah, there's all kinds of interesting sinks that are available as well. Some of the biggest ones have to do with rewetting peatlands. I didn't really appreciate how big of a deal this was until I taught this course, but peatlands store more carbon than tropical rainforests do. I think it's like 3 times as much carbon in peatlands. So peatlands, mangroves are enormous carbon storage things. So things like anytime we're restoring these ecosystems, peatlands or mangroves or rainforests, these are critically important for climate as well, being able to keep that carbon or enhance how much carbon is being trapped in there.
These will have to be the last 2 short questions.
Okay, great. And I'm glad to stay after to answer other questions too. But yeah, the more we can do, it's either decrease sources or increase sinks. We've got to do both.
Just a little story to illustrate how hard it is to make people see. But my neighbor was getting his gas car repaired up here, and he wanted a ride to pick it up. It was like 25 miles away. He wanted a ride, so I'm giving him a ride. I've got an electric car, and he's telling me, like, yeah, electric cars, they're not there yet. And I'm like incredulous, like, you're riding in an electric car right now. I've been to South Dakota, and I don't know, just even in the face of reality, like, oh, it's not possible yet.
We drove here we live 200 miles away. We drove here in our electric car. It was no biggie. Anyone who drives an electric car, push that gas pedal down to the floor wants to try it out. It's like driving in a rocket. It's a ton of fun. I was never a car guy till I got an electric car. Boy, now they're fun to drive.
I like the idea that the ocean is so big and is a great sink, but we also are hurting the ocean by adding carbon to it. And carbon dioxide to it, and can you address that?
Yeah, most of the CO2 actually that we're emitting is going to the ocean, not the atmosphere. I think it's like 90% of the CO2 actually gets into the ocean. The problem with that is that added CO2 into the ocean is acidifying the oceans, and in that acidification process, that has cascading negative effects for ocean ecosystems. This might be the most depressing thing that you'll hear all week, but coral reefs will probably not exist in 50 years anywhere on the planet. And that's simply because of ocean acidification, and it's effectively an almost unstoppable process unless we were to cut off emissions immediately. So go see your coral reefs now. But yeah, sorry to end on such a depressing note there. That's the worst. I'm the worst speaker ever. But yeah, that's this problem with CO2. It's a good thing it's not on the atmosphere, or we'd have been cooked years ago. The ocean's buying us some time, but how much time can the ocean continue to pull in most of that CO2? that's unknown. It might be that the ocean reaches a saturation point and then it all goes back into the atmosphere, and then we're also cooked. So there's a lot of unknowns here, but the unknowns aren't on whether we're causing the problem. The unknowns are around, like, at what point does this or that tipping point kind of happen? Those are that. Anyways, yeah, thank you.
And we're clearly going to need good science to even hold the level playing field on some of these problems. And science requires observation and measurement and questioning things. And please, science does not require a permanent, believable, religious-like solutions to anything. Science is questioning things and moving on. And one of the things that worries me, we're going to have a speaker next year who predicted a lot of this instability. And he did it by measuring the ice columns in Greenland. And you could look back thousands of years and see what had happened. 5 years from now, scientists are not going to be able to do that because the ice is melting and this incredibly powerful source of observation will be gone. Another thing, in 1999, I was in the State Department and was working on an international global trade conference in Seattle. Did any of you go to that conference? Well, it ended up being lovely liberal people having a riot in the streets of Seattle against global trade. And there were plenty of reasons for protesting. But what it accidentally did, in an unintended consequence, it started polarizing these science-based issues. And now the people are protesting in the other way. Then another positive thing for you to think about today, tomorrow, is the human rights of people living in hot, poor countries. Don't they deserve air conditioning? Don't they deserve cars that can get them not have to go walking 6 miles to pick up wooden sticks? But if they have all of those things, these indicators are going to go sky high. So you need to think about how do we solve those problems so that it's not just us nice people who basically are living with what a friend of mine calls rich people problems. Think of the poor people who are struggling with these things. And we'll see you next week. We're going to take a global look from the heavens with the new telescopes. So thank you for... It's on YouTube. Yep.